Hello guys, my name is MCSH. Welcome to another series on OpenComputers where we try to play Minecraft using only the OpenComputers robots. This is the second time we are doing the OCC challenge where we are trapped in this house basically. There's no way out for us. The robot can leave, of course, and it can expand the house for us, but we are not supposed to leave the house. And the rules are fairly simple. The house is anywhere where the floor and the roof are planks and the walls are made of windows, basically. Glass, not window. Right. And we have a robot companion to get started with. This is Gladys from Portal. I'm afraid of her, but yeah, we're going to make it work. We also have 64 emergency glass and 64 oak wood planks, as well as the OpenComputers manual, and a bed, and a torch. And yeah, that's it. A 3x3 room, plenty of space to work with. And yeah. So, let's quickly review our robots over here. Gladys has certain properties. It has inventory upgrades, it has internet card, it has a graphic card, it has, what else do you have? A screen, some memories, a database upgrade, a chunk loader, and a few other things. Basically, things that aren't too OP, but allow us to play the game without going outside. And if you haven't played with OpenComputers before, they are like a Unix computer in Minecraft that you can do anything with, basically. And they have a quite nice interface, and they support the Lua programming languages. The Lua programming language, and you can, give them commands, like you can tell them robot.forward. Okay, and it would, we would just go forward. That's it. And you can tell it to go back, and it goes back. Of course, you can write programs in this interface as well, and that is what we're going to do. So, let me quickly show you my setup. This is the inside of the robot that we have. This is basically the hard drive of the robots. I set OpenComputers in a way that I can type the code here because it is really hard to work with files here. Like there's basically no editor here. But whatever we wrote there, we can access here, and it is much more efficient. Right, now if I catch the test file, you can see my changes occur here. So that's how we're going to play. We're going to code there and then come back and see the results here. And yeah, that's it. Nothing else is going on. This time I'm hoping we can get we can get a robot to do a lot of different things. And yeah, alright, there's no point in wasting time, so let's start. The first thing we need to do is for our Gladys here to go outside the house, of course, just like we did before. We need a program for the Gladys to go out and then come back in, keeping everything intact, right? So Gladys, our dear friend, has certain commands like drop, swing down, count, detect down, drain up, level, etc. Basically anything that the upgrades allow it to have. And we can either program them here or program them in the editor. So I'm going to open up my editor and start programming there. Alright, so let's get started. I'm going to create a library folders in our home. Basically, I like having a little bit of structure in my code. So, and then I'm going to create a program called out.lua, in which we are creating a function called out that helps the robot to go outside. I forgot. Do we have curly brackets in Lua? Let me cheat. I feel like we do. Oh, we don't. We write end. Right. Like that. Alright, so in order for our robot to go outside, he needs to dig down probably 2 blocks, go that way, and then come up, and then do the exact opposite to go back. So let's do it. We have to write robot.swing down, and then robots that do we have semicolons in Lua? Again, I haven't used Lua in a while. We don't. Alright. So we swing down, and then we go down. We repeat that 2 times, and then that's it. We also need another file called home.lua, where we do exactly the opposite of what we did here. So we will say the function home tells us to come up twice, and then robot.place down, because we need to put back the plank that we took on our way out. Right? Yeah. I think we also need to include the robot packages in this, so I'm going to go ahead and declare that. It is require, like this. Let me cheat again. That's not helpful. Anywhere I can cheat. Maybe here. User require. Yeah. Alright. So we need to require the robot package in our home and in our out file, which I'm going to do now. Out. Right. So that should be a very basic version of going outside and coming back. So all we need to do is go into our source folder, which I'm going to create now. Home source, and then test.lua. And we'll try to require home, and then require out. Right. And then yeah, just to make things easier, I'm going to change the format here so we don't actually define a function. What's the command? Is it semicolon? Is it sharp? How do you command in Lua? How do you comment in Lua? I feel like it's something that I've seen before. Dash dash, okay. So I'm just going to comment out these 2 expressions for now, because I don't want to define a function at this time. But that's something we have to do later. Right, and so I'm hoping to show you how I do my day-to-day programming, as well as have some fun while playing Minecraft. Because this is what I do for a living, and yeah. Oh, these are in reverse, so we need to require out first and then home, and we don't have any semicolons. Right. So let's see how this turned out. I'm going to Lua source then test, and you can see that this is slowly breaking the wood, going down and coming up back up. That's great. And now all we need to do is do that while moving the robot outside. So after going down, you need to turn around and then swing forward while moving forward. Is it swing or swing forward? Swing. Oh, it's swing. Okay. So you have to do that twice, right? Let's see. So once it will be under the glass and twice it will be under the grass, right? Twice. And then you need to swing up and then go up once and then do that 2 times. No semicolons. Why do I keep writing semicolons? Jesus. Alright. This is the way we're going out of the house, and let's write how we are going back inside. So all we need to do is do the exact opposite of what we did here. So we need to go down, lowercase d twice, and then we need to turn around, then forward twice, and then we need to come up and place our block. Right? Yeah. That should be it. So, if we run our code now, there will be a slight problem, but let's see it together because it's more fun that way. The robot breaks the block, goes down, comes up, and yeah, surprisingly no problem. I thought it was going to mess up something along the way, but I guess we were lucky. Anyway, let's look real quick. Alright, now we need to actually chop down one of those trees, but it's going to be really bothersome creating the code to go outside like this. So I propose we create our move function again. If you don't remember it, we created a function called move where you would tell something like move forward 3 times, downward 2 times, and something like that, and the robot would basically just follow your command line character by character. And I would really like to have that command back. Good news is I have the source code for the previous version. Alright, just to give you an idea, this is how we implemented the move last time. We had all these if statements where we would check what the character was. We had a forward character, a back, an up, all these things. And then we have a move command where we would break our break the command into the characters and basically run it. So I actually like this one, but I'm not a fan of how this one is created. So I'm going to basically copy this one right here and implement the act from scratch, right? So here we're going to create a file named move.lua, and we're going to declare move, and then we're going to return it, right? Yeah. And then so how does this work? The move function has a path and a callback. Ignore the callback for now. In fact, I'm going to go ahead and remove it. So we have a path as the input, which looks something like this. This means that go forward 3 times, and then R, I guess that was, I don't know what R was. Maybe turn around? I don't know. And then go forward once again. Oh, this is turn right. Okay, I'm gonna change that to TR because that was misleading. Right. And then the way it worked was we would run this regular expression on our path. So the expression looks for something that is not a comma, and basically, so it would break. So the word would be F3 and then TR and then F1, and then in that we would look for a number. So it would be 3 and 1 and 1. So this would be 1 because we have an OR statement here. So if we are not able to find any number, we will assign a 1 to it. And then finally we have to find out about the the command part of the word, which would be F, TR, and F. And then we would basically repeat the command number of times. Alright? So now all we have to do is implement the move.act function, which I'm going to start working on it now. So move.act, you get a word, and yeah. Alright? So previously, we implemented move.act using a bunch of if-else statements, but I think it would be much more efficient if we use tables. Right? So I'm going to create a command table here, or possibly even outside, I don't know. Okay, let's do it here for now, where we can say things like F means robots.forward. Right? I'm not going to write the parentheses here because this is not a command. I don't want to run the function here. I'm just going to say F means that one, and then repeat that for all of the other characters, like B means robot.back, and then TR means robot.turn right. And then, yeah, we're just going to write all of that. And then, whenever we want to run this function, I'm going to find the function first. So I will say local f. Oh, we have to declare this. Local f is look up what the word is in our table. I think this is how you do it. I might be wrong. I can look it up. I should probably look it up. Let's look it up. So Lua dictionary lookup. Let's see. Oh, it's called a table, not a dictionary. Okay. We can basically extract in this way. Is there a way to define them? Okay, we can define them, but it has to be inside the brackets. Alright, so we can do this, which is even better. I'm going to use this version. Okay, so FBTR. Great. and then we extract our command and call it. That's it. Function arguments expected near dot. What function arguments did you expect? Okay, because this should be like that. Okay, that's a really basic way of using it. Let's see if it works. I'm going to open up Lua, and I'm going to require my move function. Okay, there was an error somewhere. Maybe it needs to be like this. Yeah. Now I should be able to say F3, and it goes forward 2 times. It couldn't go a third time because there are glasses in front of it. But it should also do B2, and it should do forward 2 times, backward 2 times. Alright, that's perfect. And this was surprisingly quick. Like the last time we did this, it took us 2 or 3 episodes just to get to here. Anyway, we need to redefine our functions because, you know, that was tedious. Writing the out and home function like that was really hard. So let's rewrite those functions. With the new move function, we have the forward, backward, turn right. We have the turn left as well, like that, and then turn around. And we have swing. We have swing down and swing up. We have up and we have down. That should be all. So let's see if it works. We have to close the Lua, open it up again, import our move function, and then move that move up once, forward once, down once, back once, and it can't do it. Of course it can't, because this is OpenComputers we're talking about. Can you do forward once? Yeah. Can you do backward once? Can you do up once? No. Why not? Why can't you move up? Is it because I just defined it and you can't reload your library? If that's the case, I mean, I can cheat and see how I fixed it last time. Right. Okay, so we have to tell our robot to forget about the move function that it currently knows, like this. Package dot loaded, was it? Yes. That move equals nil. So this will force the robot to forget the move function that we defined earlier, and then we can require it again, and now it should be able to do this. It is not. That's weird. Do you have a up function? Of course you do. Do you have a down function? Of course. So what's the problem, buddy? Up, down, that should be fine. I mean, the worst thing is I cannot like scroll and see what the function is. See? But I guess we can always turn it on and off again. Turn it off and on again to see if things changed. And then we can require them again. Make that move up once, forward once, down once, and back. Okay, it worked. Which is really weird, but it worked. So, let's go back to our code here. I'm not going to write our home and out functions again like that. So I'm just going to create a new function called addresses.lua, in which I say addresses is a new variable, and out is down, swing down, down, swing down, then turn around, forward, swing, forward, swing. Okay. Do you see the pattern here? We are repeating every two characters together. Maybe there's something we can do there. Maybe we can define a new function, something like okay, let's think about that in the next episode. Let's just make this work. So forward swing, that was how we did it, right? No, completely reverse order. So out would be swing down, then swing down, then down, turn around, swing forward, swing forward, swing up, swing up, up. And home would be, let's see that one. Down twice, turn around, forward twice, up twice, and then place stand. Okay, we need to define place stand as well. So let's go there and define a PD as robot.place down, right? And say, oh, this is in the wrong folder. Let's move that to home lib. Okay. Refresh. Great. We no longer need our out and home files, but I'm just gonna keep them for now. But we do require to change here as well. Right, so I'm going to say local address is whatever is in the file local address, and the move is here. Now move address dot out, move address dot home, right? We need to change it like that. I think that should do it, actually. Let's cheat and move this from before. This forces OpenComputers to reload the file every time we run it. Okay. I'm going to turn it off and on again, and tell it to run the test file. It's breaking that. Going down. Up. Down. Great! It worked! That was awesome. Alright. Okay. Thank you for joining me in this episode. Hopefully in the next ones we're going to keep doing what we did here. Do let me know if you have any suggestions or questions or anything at all in the comment section down below. And of course feel free to play with me. I would really appreciate if others start playing OpenComputers challenge as well. This was MCSH and thank you for joining me. Bye bye.